Hello and namaste everyone. Welcome to today's explainer. आज हम एक बहुत ही crucial chemistry topic को decode करने वाले हैं. If you've ever wondered why lemons taste so sour or why soap feels super slippery, you are absolutely in the right place. We are going to demystify acids, bases, and salts, taking this classic class 10th science topic and making it crystal clear. So get ready to upgrade your chemistry knowledge. Okay, let's dive right into it. Now, I know looking at this massive mind map right off the bat might feel a bit overwhelming, but honestly, don't worry at all. हम इसको बहुत ही easily step-by-step breakdown करेंगे. Just think of this as our ultimate treasure map. By the end of this explainer, every single branch, formula, and reaction you see is going to make perfect sense to you. Here is our game plan for today. First, we'll meet our main characters, acids and bases. Then we'll explore the magic of indicators, see some actual chemical reactions in action, figure out how salts and neutralization work, and finally, measure it all with the pH scale. Let's get started.
Part 1. Meet acids and bases, the two chemical rivals.
Let's start with the stars of the show. You can really think of them as the ultimate chemical rivals, just complete opposites that are destined to interact. एक तरफ है acids और दूसरी तरफ bases. Acids, well, they've got that sour taste. Just think of biting into a super khatta lemon. Their real superpower, though, is producing H plus ions in water. Plus, they turn blue litmus paper red. Now, flip the script. Bases have a bitter or kadwa taste. They feel slippery to the touch, kind of like soap. Their signature move, producing OH minus ions in water. And yep, you guessed it, they turn red litmus paper blue. It is literally a battle of the H plus ions versus the OH minus ions.
Now, what's really fascinating is how you can spot these rivals just by looking at their chemical DNA. Take a look at the general formula for acids. You see that H for hydrogen right at the front? Like in hydrochloric acid, HCl, or sulfuric acid, H2SO4. That's hydrogen taking the lead. Now check out the bases with their general formula MOH. There's that recognizable OH or hydroxide group tagged right at the end. You can see it perfectly in sodium hydroxide NaOH and potassium hydroxide KOH. The chemistry literally writes itself into the name. Kitna simple hai, right?
Moving on to part 2, the magic of indicators, chemical traffic lights. So if acids and bases basically just look like invisible, clear water, how do we tell them apart? Enter indicators. ये बिल्कुल chemical traffic lights की तरह काम करते हैं. Take litmus for example. It flashes red for danger in an acid and switches to blue in a base. But phenolphthalein? Man, this one is like a magic trick. In an acidic or neutral solution, it is completely colorless, just hiding in plain sight. But the second it hits a basic solution, boom, it turns this brilliant, vibrant pink. And methyl orange gives us a warning red in acid and a sunny yellow in a base. These color changes are exactly how chemistry visually speaks to us.
All right, part 3, action and chemical reactions, nature's recipes.
Now that we can easily identify them, it's time to see them in action. I always say, think of chemical equations not as boring math, but as nature's cooking recipes. Mix the right ingredients and you cook up entirely new dishes. Here's our first classic recipe. Take an acid, mix it with a metal, and you get a salt plus hydrogen gas. For instance, 2 molecules of hydrochloric acid plus some zinc gives you zinc chloride and H2 gas. See that upward arrow next to H2? That means the gas is escaping into the air. And this hydrogen gas is highly combustible. If you brought a match near it, you'd literally hear a pop sound. How cool is that?
Let's level up that recipe. What if we swap out the pure metal and use a metal carbonate instead? Well, acid plus carbonate gives us salt, water, and now carbon dioxide gas. देखिए, when 2HCl reacts with sodium carbonate, or Na2CO3, we get sodium chloride, yep, regular namak, plus water and CO2 bubbles. By adding that carbonate, we essentially just added some fizzy carbon dioxide to our chemical dish.
Of course, bases have their own special recipes too. When a base meets a salt of a weak acid, it's basically a chemical dance where they just swap partners. Watch what happens when sodium hydroxide reacts with copper sulfate. The sodium ditches its partner and pairs up with sulfate to make a new salt, sodium sulfate. Meanwhile, copper grabs the hydroxide to form a brand new base, copper hydroxide. And that downward arrow you see, it means it forms a solid precipitate that sinks right to the bottom. Partner exchange, completely done. Before we get to the grand finale, check out this reaction. A base reacting with a non-metal oxide like carbon dioxide gives us salt and water. So, sodium hydroxide plus CO2 yields sodium carbonate and water. Now, here's the crazy part. Since we know a base plus an acid normally equals salt and water, this reaction gives us a massive hint that non-metal oxides actually act just like acids, which perfectly sets the stage for our next section. Part 4. Salts and Neutralization. Finding Balance. This is it, the main event, the exact moment our two chemical rivals finally meet face to face. When an acid and a base combine, they completely cancel each other out in what we call a neutralization reaction. The H plus ions from the acid and the OH minus ions from the base lock together to form, well, H2O, good old water. And whatever is left behind, that forms a salt. So acid plus base always equals salt and water, like sulfuric acid and sodium hydroxide totally neutralizing to give us sodium sulfate and water. It's absolute chemical peace.
So let's talk about these salts. नॉर्मल लाइफ में जब हम सॉल्ट बोलते हैं, हम सिर्फ खाने वाले नमक के बारे में सोचते हैं, राइट? But in chemistry, salts are these powerful ionic compounds. They're usually neutral because they're the offspring of that massive acid-base clash. But get this, they have a hidden superpower. When you dissolve them in water, creating an aqueous solution, they split into ions and can actually conduct electricity. No way, right?
Structurally, a salt is just a positively charged cation locked in a hug with a negatively charged anion. Everyday examples of these incredible compounds, while we've got NaCl, your standard table salt, potassium sulfate, calcium carbonate, which is literally the chalk and limestone around us, and sodium carbonate, which you'd find in washing soda. So yeah, this isn't just abstract science. This is real-world chemistry sitting right in your home. And finally, Part 5. Measuring with pH scale, the ultimate ruler. Okay, so we know acids and bases exist, but how do we measure exactly how strong they are? We need a ruler, and this brilliantly illustrates the dead center of our chemical universe, the number 7. On the pH scale, a perfect 7 is pure, unadulterated neutrality. No extra H plus ions, no extra OH minus ions. Just perfect balance. Kind of like pure distilled water. This right here is the ultimate zone of peace. But what happens when you step out of that peaceful zone? The pH scale maps this out visually from 0 to 14. Drop below 7, moving down towards 0, and you are officially in the acidic zone. The lower the number, the more aggressive the acid. But if you climb above 7, heading up to 14, things get basic or alkaline. The higher the number, the stronger the base. It's this beautifully simple spectrum that dictates the chemical makeup of literally everything around us. So, as we wrap up today's explainer, I want to leave you with a quick thought. From the sour food on your plate to the slippery soap in your shower, आपकी daily life का pH क्या है? Seriously, take a look around your house today. Try to spot the hidden acids, bases, and salts that are secretly running your world. Thanks for hanging out with me today, and keep questioning the chemistry around you.